This episode of Fluid Power Forum is sponsored by eShipping, a distribution chain management company offering transportation, warehousing, and technology services. Learn more at eshipping.biz.
I see, honestly, fluid power kind of entering a renaissance of sorts with all the electrification and electronic controls that are being added into devices and the cost of all these electronics going down. You're seeing smart pumps, you're seeing smart valves, and all these intelligent devices. So I think we're headed into actually a real fun time in the hydraulics world.
Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of our show, as always, we ask you to follow us on Twitter. We're spreading the word far and wide on that social media platform. You can find us there at the NFPA. And while you're there, you can share interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. That is one of the ways we, in fact, source topics for our podcast. If you see an interesting application of fluid power and you want to learn more about it, you can share it on social media with our hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, we ask that you subscribe to our show. Now that you found us, if you subscribe, you'll get automatic feeds for future episodes. We're on Apple Podcasts, we're on Spotify, we're on a lot of the other podcatching services. Wherever you find us, go ahead and subscribe and then give us a quick rating. That really does help spread the word and let more and more of our friends in the industry join in on these important conversations. On today's show, we have two guests, Bob Grinstead and DJ O'Connick. DJ is the ESS Group Manager from Nott Company, and Bob is the founder and chief executive officer from Zeuss Electric Chassis, one of Nott's many customers. They work together on a really interesting application of fluid power, and so we invited them into our forum today to learn more about that as it deals with the latest hydraulic advancements in truck chassis applications. So Bob and DJ, welcome to Fluid Power Forum.
Thank you.
Glad to have you both on the show today. I'm hoping that you can tell our listeners a little bit more about yourselves and about the company that you represent. DJ, why don't we start with you? What's your background?
I've been in the fluid power industry in various roles for about 25 years now. Started off out in California developing test equipment for the aerospace industry. While I was with that company, I was also given an opportunity to go over to our London office and manage that for a couple of years as well, supporting our overseas customers. From there, I actually ended up moving back to California to work for a company that developed gas separation equipment through both cryogenic distillation and membrane technologies. And from there, I actually ended up moving back to Minnesota and starting a heavy equipment manufacturing company. And then ended up getting back into distribution. And now I'm the manager of the ESS Group, or Engineered Systems and Solutions Group, at Nott Company. And Nott Company is made up of 4 different divisions: mobile fluid power, industrial fluid power, industrial engineered solutions, and engineered material solutions. The ESS Group that we manage supports both the mobile fluid power and the industrial fluid power divisions. We have a team of 9 engineers in our group. And honestly, we're in the process of looking for more engineers. So if anybody out there is looking to join us here in Savage, Minnesota, feel free to get in contact with me. Sorry for the plug there, Eric, but just wanted to throw it out there.
No problem. If we can help solve the workforce problem in our industry through Fluid Power Forum, we're more than happy to do it. So yes, please.
That'd be great. And our team members have quite a varied experience. in both software development, mobile fluid power, and industrial fluid power technologies, and 3D design to develop manifolds and custom products for application.
Right.
And our entire team is cross-trained as well, so they have a good understanding of how their technology fits in with the rest of the team members. As an example, almost everybody on the team can program like Parker I can, but for more complex systems, such as what we did on the Zeus project, we have a dedicated team of software engineers that can do higher level programming like C++ and Qt, sometimes referred to as Qt, and also work in Visual Basic, and have also developed software, cell phone apps as well.
It's a really nice detailed description of all the different services that Nott provides. I know, in some indexes, you guys are probably listed as a distributor, but that really shows you the kind of value add that a lot of companies like Nott provide to the services and the industries that we support. So thank you for that overview. That's great.
Yeah, thank you.
Yeah. I'm curious, DJ, before we ask Bob to introduce himself, your career history there that you went through at the beginning is pretty varied in terms of the different activities. Has fluid power been a through line for you that whole time, or did you kind of return to it after a while?
No, I've always been heavily involved in fluid power, even the aircraft test equipment. It was mostly the flight actuators on the vehicles.
Yep.
And obviously heavy equipment has plenty of fluid power on it. And then obviously in distribution with the fluid power company.
Right.
It's been a thread throughout my entire career.
That's great. And I know you continue to work on interesting projects in that space. But let's go to Bob and ask Bob to give us a little background on him and tell us a little bit more about Zeuss Electric Chassis. Bob, go ahead.
Yeah, sure. Thank you, Eric. My name is Bob Grinstead. I'm the founder, Chief Executive Officer at Zeuss Electric Chassis. My background is primarily mechanical engineering, systems, and vehicle design. Started my sort of tenure, cut my teeth at Spartan Chassis, now Shift.
Mm-hmm.
Was there about 15 years, working within the emergency vehicle and special vehicle engineering teams. And while I was there, so we touched on and developed the fire trucks, some special vehicles for mining equipment, MRAPs. We did buses, electric buses, and electric trucks there back in the early 90s through late 90s through 2000s. So I had a lot of experience right out of school in a special vehicle manufacturing engineering realm.
Mm-hmm.
After I left Spartan, or Shift now, I spent the past 10 years or so as a consultant and contractor for engineering services per se, within the sort of this family of special vehicle manufacturers or heavy truck manufacturers, supporting large and small OEMs, some government projects, and EV projects. And in total, been within, I guess, this industry about 25 years or so. And ironically, and I think for good sake, many of the either manufacturers, suppliers, OEMs, and users are within this sort of, I'll call it footprint of what we're doing here at Zeuss.
Mm-hmm.
And it's been interesting because you've probably heard this before out of a few people, is you try and get out of industry and somehow you get pulled back in one way or the other.
Right.
And it's been like that, I think, a little bit.
Yeah.
So that's my background. And at Zeuss, we are an electric vehicle manufacturer. We are located in White Bear, Minnesota. Our business model enables fleets, public and private fleets, utility, to fuel uncompromising trucks using their existing OEM bodies and channels of market. So we don't disrupt what they're doing relative to their business and how they make money. We just enable electrification. We're the only ground-up platform designed by truck and system industry experts and holistic integration approach that meets, or actually exceeds, without compromise. We do engineer solutions for vocational truck work industry and address both environmental and industrial needs.
That's
So
great.
that's what That's what Zeuss does.
Yeah, I mean, again, and that's a great overview as well. I appreciate those descriptions. But just to clarify, so you guys, you're electrifying existing trucks. Did I hear that correctly?
We have a ground up design
Yeah.
that is all electric and enables the current bodies on the back end, like a dump truck or utility bucket truck or service body, to still fit on to fit on a chassis. Meaning we don't force the end users or the current equipment to compromise what they have for solutions. We just enable it to have them to be electric.
Okay, great. That's good to know. And what kind of work trucks are we talking about primarily?
Yeah, so class 4, 5, 6, so roughly 14,000 pound gross vehicle weight rating up to about 22,000 pounds.
Okay, so a wide range of potential applications.
Correct.
Great. So what is the relationship between Nott and Zeus? How did you guys first come together to work on projects together?
We were introduced by a common company that both Zeuss and Nott were working with at the time. And our division manager at that time met up with Bob and just introduced what Nott Company was doing. And it seemed like it was a good fit for the two companies with our previous history in all the work truck market and heavy vehicle market. And the electrification that we'd been doing on some of those applications. And since we're also a distributor of most of the components required to do the electrification of vehicles and control of vehicles, it really created a mutually beneficial relationship between the two companies. So as it currently sits, Zeuss is responsible for the engineering design of the core vehicle itself and the higher value propulsion parts on the vehicle as well, like the chassis, cab, brakes, steering, the propulsion inverters, and the batteries. And then Nott is responsible for providing the electronics, the hydraulics, and the engineering for the integration of those components into their vehicles.
It sounds like a great partnership, that was able to develop because of the two sets of expertises that could come together. Bob, I asked you previously to tell us a little bit more about the type of vehicles that Zeuss is developing or working with. Maybe I'll give you a moment to shine here. Like, what sets the Zeuss products apart from other electric vehicles that people might find on the market?
Yeah, it's actually great question, actually. So again, coming from a industry of special vehicles, knowing today the current work truck is typically built on an F550 roughly, and it's think of that truck whether it's Ford or Ram or Chevy, and they are mass manufactured and used in those industries as best they can. It's a good tool, but it's not the best tool that can be used within certain applications for work trucks, where even though it's a commodity piece, people need wheels to move their body around. Because at the end of the day, this work truck market or the special vehicles market, it's all about the body, the back end, and enabling work to be done. The truck itself, it just needs to go from point A to point B. However, with Zeuss, besides being electric, which is one obvious big difference, the actual design of this truck is meant to last a very long time. It's not a throwaway truck. It's not a commodity anymore. It's an actual tool in similar fashion as a body, relative to lasting longer than the current sort of traditional trucks. But also the biggest piece is the integration, the holistic approach as far as enabling the bodies to be attached electronically and physically and hydraulically to the back ends, where today the mapping of you buy a F550 or class 4 to 6 truck, there's a lot of modification that happens and a lot of third-party devices. And at the end of the day, you come up with a truck that works for the most part, but it's not the most streamlined method to provide a work truck, where Zeuss actually has those relationships, like with Nott Company, on the integration of certain components electrically, the programming piece, and also our other partners like our battery manufacturers, our body OEMs like the Knapheide and the Red Ink through EVX. That's really what sets us apart is we look at this industry as not just throwing an electric truck over the fence and seeing what happens. It's coming together as a team, a very effective team, and saying how do we solve this electrification problem that really the world is having, and specifically the East and West Coast relative to switching from diesel trucks to electric.
Yeah.
We just can't solve it by themselves. We just can't do it. That's why we have a very robust and very effective team around us.
Well, it sounds like that system-wide integration concept is really core and critical to this, to make this work right? It's not just bolting on a bunch of new stuff. It's actually designing it from the ground up and making sure everything talks to all the other pieces as effectively as possible, right? I don't want to put words in your mouth, but that's what it sounds like to me, at least.
That is exactly what it is.
Yeah.
So thank you, Rick.
Yeah, that's great. No, as I'm sure our listeners know, electrification is a huge trend in not just the truck industry, but a lot of different industries that are reliant on hydraulics. And sometimes people think that means we're getting rid of the hydraulics on these applications because, after all, they're electrified. But this is one of those places where that's truly not the case, right? I mean, we still have, what kinds of things are hydraulics still doing on these trucks? Maybe DJ can respond to that.
Yeah, even on, the most basic chassis, there's still hydraulic functions on these vehicles, like steering and braking,
right.
which we're using an epump to supply the hydraulic fluid to those operations. Then also, like Bob mentioned, all the different work functions that are added to these vehicles typically require an additional pump on there as well. So in reality, you're really not displacing any of the hydraulic systems. Most of the time, you're just changing the prime mover of those systems, right, from an internal combustion engine to an electric motor. And there's still, it's tough to beat power density and the cost of hydraulics. And there's lots of things that you just can't do with electric actuators yet, like force control and linear applications. So you're really not displacing hydraulics at all. You're just changing how you're operating that pump at the beginning of the system.
Yeah. You called it an e-pump, if I heard you correctly, right?
Yeah, an e-pump or EPTO. Really it just stands for electric pump or an EPTO.
Let's talk about
different people refer to it as different things.
Let's talk a little bit more about that particular component. But we've reached a point in our show where we do have to take just a quick break because we want to make sure our listeners are brought up to date on other opportunities in the fluid power industry. NFPA's latest edition of the U.S. Fluid Power Industry Brief is now available for download from the NFPA website. The brief is a convenient compilation of industry facts and data which can be used to understand and promote the growing fluid power industry. You can use the brief to encourage a student to pursue a career in fluid power, to educate your network on the value of your business and industry, or just better explain to a family member what it is you do and why you love it. To view and download the brief, head to nfpa.com and look for the U.S. Fluid Power Industry Brief under the Industry and Stats tab. Go there now, download that file, and share it with anyone you think would benefit from our content. Working together, we can promote and grow the fluid power industry. Okay, we're back from our break, and I'm talking with DJ and Bob from Not and Zeus Electric Chassis, and we were just about to talk more about one of the hydraulic components, electrified hydraulic components called an e-pump that DJ was just explaining to us. So tell us a little bit more about exactly what that is. What are the benefits of using a technology like that?
Yeah, there's many different ways to design up an effective epump for the system. Here at Nott Company, I mean, we design each one of them to meet each customer's needs or each application's needs. In the case of the Zeuss vehicle, we have a very simple system for the steering and braking, but we also have the flexibility to add more complex epump systems to that vehicle as well, to do things such as garbage trucks or other complex functions. But the steering and brake unit on the Zeuss vehicle is just a gear pump close coupled to a Parker GVM motor that's run by a Sevcon inverter. Since the traditional brake booster and power steering modules that are used on the vehicle both have unloading circuits, we don't have to do like a pressure pump or anything very complex. And also it gives you the fast response. You have all the fluid available all the time for those functions on the vehicle. But we're also able to create more efficient systems when we aren't using closed-centered devices. As for like work functions or on the epumps, the sky's pretty much the limit on what we can do to make the systems far more efficient. On other work function systems, for some of the designs, we could close couple a variable displacement pump to a Parker GVM, and by varying the displacement of the motor, we can actually optimize the response to the hydraulic system, while at the same time operating the pump within its most efficient parameters. Right. And we can also monitor the flow and pressure to maintain a constant flow or a constant pressure, whatever that particular application requires to be operated in its optimal conditions.
So DJ, I'm kind of curious, the marriage, if you will, between the electric motor and the hydraulic pump that is now the combined package that we're calling this epump. How compact is that? How well integrated are they? Just two devices stuck together, or are they more integrated than that?
We've done some very simple ones where it's just two units married together. Yep. But we also have some proprietary technology that we've been working on as well to package these into sound enclosures and add a little bit more complex controls by monitoring the flows and pressures in the system to meet that system's needs as well.
That's great. Yeah, it's, as I know, it's a growing segment, if you will, in the industry, and coming up with self-contained, electrified fluid power actuation devices. They go by a lot of different names, but
everybody has their own little acronym.
Exactly. We're happy to call them epumps for the length of this conversation, though. So we'll just ground ourselves in that brand ideology, if you will. So where on the trucks are we going to find this technology, these epumps? What specific applications are they? What functions are they performing, if you will, on the truck? Maybe Bob can answer that one better.
Yeah, I think Eric. Yeah, the primary location, or at least purpose, is what you described as your brake and steering. It's required for compliance and drivability. But there are other locations or uses within the work truck industry. Would be truck-mounted cranes. Would be bucket trucks, like what you see around utilities or telecom. It would also include subsystems for aux cord or tools that require hydraulic use off of like a mechanics truck. So it's what's nice though, because we're not dealing with a PTO anymore or engine driven system, is that epump can be located anywhere on the chassis, and which is fantastic, and it can be sized per the equipment. So it can be multiple uses, multiple locations. Okay. And yeah.
What about that interface with the batteries? Is that are there any challenges, or is that a unique configuration?
The only which I think DJ can appreciate is supply chain. That's probably the biggest constraint. But other than that, no. So,
But yeah, I mean, one unique thing about the Zeuss system too is that all these epumps have access to the propulsion batteries.
Right.
And what you're finding is a lot of the manufacturers out there don't allow access to those batteries either. So it's really cool in there because now you don't have to have two separate charging systems or any other complexities for their customers to deal with. But that's one thing that definitely sets them apart from some of the other guys out there. The other cool thing is by doing all of that off of that central system, we've been able to consolidate most of the functions into a primary screen in the system, which is helping reduce the cab clutter in there as well.
Okay. Yeah. So I didn't realize that would be a challenge, that as you call them, the propulsion batteries are inside of a lock box somewhere, and a lot of other trucks you can't get access to them. But because you guys are designing this from the system up, you can make sure that those connections take place.
Yep. Yeah, that's correct. And and again, that's what we talked about earlier about the current vehicles. And I think people understand, like, the Ford Lightning coming out, and you have like Rivian coming out, and you ask the question of, hey, I need to pull about 5 or 10 kilowatts off your battery pack to do this thing, and
right.
And again, those folks are in the realm of doing business to make passenger trucks. By asking those folks up forward and say, hey, can we just tap into your high voltage power and do this work? And you can probably appreciate the answer,
right?
Because of what it is. But that's why we're Nott Company and Zeuss have thought this very well out as far as an architecture plan to ensure that as we attach and connect high voltage, which our main battery pack. So it's planned that way. We are ready to sort of clarify the question of, hey, I need this special crane, I need this special equipment to be hydraulically driven, and the answer is, okay, what's your flow and what's your pressure, and let's have a conversation.
Yeah, it's an interesting way to overcome what would otherwise be a pretty significant challenge, I would think, to the efficiency of the overall system. So. I'm curious, are there any other challenges like that you're discovering we need to find a creative workaround for?
Yeah, one of the unexpected challenges that we've had to deal with introducing these e-pumps in general in these systems is once you remove that internal combustion engine, now you actually get to hear what hydraulic systems truly sound like. And to seasoned operators, all of those noises historically meant that there were problems with their system once they got loud enough that they could hear them. But in reality, it's just what the system has always sounded like. They just cannot hear it over the combustion engine. So we've actually had to develop a bunch of sound isolation technologies that we actually are pursuing some patents on that are making their debut on these Zeuss vehicles.
It's an area that's an interesting perspective. I've actually heard that before. That the noise, if you will, is not a problem as long as there's something louder nearby. And when you take that other loud thing away, suddenly hydraulics is now the loudest thing on the machine. So there's a lot of innovation going on in that space as well. Are there any other challenges that you guys are working on?
I think from Zeuss to end user, a challenge is the actual conversation, the message. Because the end user operators, they understand at a pretty high level that there's no engine anymore, there's no traditional PTO, there's ePTO. And then the question very quickly turns into, okay, that's electric driven. I get that. And then they ask a question about how do you control it? What is the limitations? And can it still do the same work?
Mm-hmm.
And once you answer those and go through those, it becomes a little clearer. And then the fun dialogue is, and this isn't sort of specific to EPTOs. It's hey, end user, we probably need to understand how many kilowatts of power you're using on your jobs by using the bucket or a crane or hydraulic equipment. And then the look we get is, what do you mean? Because at the end of the day, we need to convert work to kilowatts to then say, okay, how big your batteries are,
right,
or how big the batteries pack we need to configure for the vehicles. But it's a good dialogue, because at the end of the day, it's an engineering science as far as the conversion piece, but
right,
the end users aren't used. They're just used to turn the truck on, put diesel and work, and then when the truck runs out of fuel, they refuel it and keep on doing the same thing again.
right.
In this case, to be hyper conscious of, we are still to do work. It's just we're not using diesel anymore; we're using electricity.
Right.
So it's a fun conversation as far as they get it, as far as it needs to go to EPTO, and then we get into a really interesting, I'll call it a quasi business engineering discussion between the
Sure.
operators and Zeuss.
Sounds like there's more math involved doing it this way.
A tiny bit.
Which is sometimes a great conversation to have, depending on who you're talking to. So, well, I know we've been talking about some of the challenges, but I know one of the benefits, of electrifying fluid power systems is that it actually allows the fluid power system to shine a little bit more. So maybe you guys can speak to that. Like, how does electrification, how does this process demonstrate the capabilities of fluid power even better than they otherwise would be?
Yeah, like we talked, alluded to a little bit earlier. By putting that variable speed motor at the close coupled to the hydraulic pumps, it gives us very precise control over the speed going into the pump, and then we actually get a lot more data back from everything going on in the system.
Mm-hmm.
And we can add additional sensors to get even more accurate data. And now you can create a hydraulic system that's only producing what is required. And then you can adjust the pump displacement, the speed of the motor to give you optimal operating conditions all the time.
Right.
And I mean, efficiency is so important once you're switching over to batteries as well, because the longer you can run off of a charge, the more work you're going to get done. The other cool thing is, with all these electric devices, we have access to all kinds of data that we didn't have before, to the point that we can send it up to the cloud and run calculations on it to start figuring out when things are going to fail rather than waiting until they fail.
Mm-hmm.
So that you can have scheduled maintenance and minimize your downtime on your jobs.
It really allows the hydraulics to be even more precisely controlled and even better maintained as a result, it sounds like, at least.
Yeah, absolutely.
Yeah, that's great. Well, I'm curious where you guys see this. You guys are obviously having a good deal of success with this collaboration and with these new system approaches, as we've been discussing. Where do you see this going next? Where do you see this technology advancing over the next couple of years?
I mean, I see, honestly, fluid power kind of entering a renaissance of sorts, with all the electrification and the electronic controls that are being added into devices, and the cost of all these electronics going down. You're seeing smart pumps, you're seeing smart valves, and all these intelligent devices. So I think we're headed into actually a real fun time in the hydraulics world.
That's great. Yeah. And Bob, from your perspective, what would you concur with that, or what's your thoughts?
Oh, absolutely. There's and I'd agree with DJ's summary as far as a renaissance. It is we can almost let the imagination go for the most part with the current hydraulic device manufacturers. And I'll use the example of again, going back to a crane or a boom or anything with hydraulic cylinders or motion control that way, is you're not limited anymore as far as a PTO. You have on-demand hydraulic fluid power at a performance that you can determine. And so you can resolve space constraints, you can resolve to DJ's point as well, the preciseness and performance of those devices now. And that's going to get real exciting, in my opinion. Yeah. It's going to get actually very exciting. So
that's great. Yeah, I wish we had more time. There's only so much ground we can cover on our show. If people are interested in learning more, how can they contact you guys? Bob, why don't you start? What's the best way to reach you at Zeuss?
Yeah, so go to the website. It's probably the best way. It's www.zeusselectricchassis.com. And you can find our product and company information, and then go to contacts page and get in touch with our team. That is the quickest route.
That's great, and we'll make sure to put links to all of those addresses and web addresses in the show notes to this episode, as we will do with DJ's information as well. So, DJ, what's the best way to get a hold of Nott Company?
Yeah, similar to Bob, the best place is to start at our website, which is www.nott, which is with 2 T's, so nottco.com. But honestly, feel free to reach out to me directly as well. My email address is dj.okonek@nottco.com, or even on my office number at 651-415-3535.
That's great. As I said, we'll put all of that information in the show notes as well, so people can access it there. Well, great. So that is going to wrap things up for this episode of Fluid Power Forum. I want to give my thanks back to Bob Grinstead and DJ Okonek, who have been my guests. As you said, check those show notes to get that contact information, and I know they would appreciate having our listeners reach out to them to learn more about this exciting partnership. Remember, if you like our podcast, please follow us on Twitter. You can find us there at the NFPA, and make sure to share those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. Also, to see the latest fluid power technology and learn from industry experts, you should be making your plans now to attend IFPE, the International Fluid Power Exposition. Our next show will be in March of 2023 in Las Vegas, Nevada. For more information, you can visit ifpe.com. Fluid Power Forum is a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, reminding you to join us next time in the forum.